All right, folks, here we are. We're looking at number 17B from test 1, and just a little reminder of how we deal with rational functions, how we add them. Remember, you need a common denominator, so we have to make sure that these denominators are the same before we can add them together, and obviously they're not. So we need to change these fractions so they have the same denominator. So we're going to multiply both of these by a fancy form of 1. What's missing from the first fraction is x minus 1 from the denominator. So by multiplying by x minus 1 over x minus 1, I'm really multiplying by 1. And then over here on the right, I'm going to multiply by x plus 1 over x plus 1, which is also a fancy form of 1. So now, when I look at this, I'm going to have x minus 1 in the numerator and 2x minus 1 all over x minus 1 times x plus 1. And in my second fraction, I'm going to have 3 minus x times x plus 1 all over x plus 1 times x minus 1. So now we see that our denominators are the same. They're written in a different order, but they're the same. So I have to go ahead and simplify the numerators of each of these before I can add. So in the numerator here, I'm going to get 2x squared minus 3x plus 1. And in my second one, I'm going to get 3x minus x squared minus x plus 3 all over my denominator. And when I reduce all that, it becomes x squared minus x plus 4 over my denominator that I created. And that's how you do that problem. Okay. So on to the problem that you may have had with the rationalizing a denominator when you have a compound denominator. So you're given 2 minus radical 3 over 5 plus radical 3. Here we need to multiply by a fancy form of 1 again. So I'm going to choose 5 minus the square root of 3 over 5 minus the square root of 3. We know we call that the conjugate. Sorry for my handwriting. All right, and then when we do that, we see that we get, we have to FOIL this. So I'm going to get 10 minus 5 square root of 3 minus 2 square root of 3 plus 3, right? Because negative square root of 3 times negative square root of 3 is going to give me plus 3. And then my denominator is going to be 25. I don't think I should have to write this, but just in case you see it, plus 5 radical 3 minus 5 radical 3 minus 3. So we can see that those middle terms are going to go to 0 when they're together. And that allows me to simplify this to 10, oops, sorry, not 10, but 13 minus 7 radical 3 in the numerator all over 22 in the denominator. And that problem is done. All right, and then let's look at 17a, simplifying radicals. This will come in really handy in geometry. So you're given negative square root of 12 plus 5 square root of 27 minus the square root of 18. And so we need to simplify each of these. So we see square root of negative 12. Hopefully you're seeing that as the square root of 4 times the square root of 3. So we're going to simplify that to just negative 2 square root of 3. And similarly, 27, right, is square root of 9 times the square root of 3. So we can switch that up to 5 times 3 times the square root of 3. And then similarly here, 3 times square root of 2. And we put that all together, we see these are like terms. So we have negative 2 square root of 3 plus 15 square root of 3, which is going to give us 13 square root of 3. And the negative 3 radical 2 can't be changed or combined because it's not the same radical or radicand. And that's it. So that's your final answer for 17A.